I'm Chris Bartholomew. I'm the CEO and founder of Kesque, and I'm going to give you a demo today of what Kesque is all about. First things first, what is Kesque? Kesque is a streaming and queuing service. So it's a service that lets you move data around, either whether that be events, like clickstream events or logs or metrics, or do message queuing with acknowledgments. So send a message, ensure that it gets delivered, have the receiver acknowledge the message. This is kind of used in sort of message bus type implementations, or if you're doing microservices integrations with asynchronous messaging. Kesque is available in AWS, Azure, and GCP, and other clouds as required. And the key thing about Kesque compared to lots of other services is powered by an open source project called Apache Pulsar, which is a next generation messaging and streaming software. Pulsar was created by Yahoo in 2016 because at the time they didn't find a solution to the kinds of problems they were having. So they built their own, sort of took the best of all different projects, and they've been using it in production since. When I say best of projects, it kind of was inspired by some of the functionalities of Apache Kafka and RabbitMQ, combining the capabilities of those two open source projects into a single platform. You can connect to Kesque using Pulsar clients. It's a fully compliant Apache Pulsar implementation, and there's multiple client types: Java, Python, Go, C, etc. And Apache Pulsar itself is an increasingly popular project. It now has over 6.6 thousand stars on GitHub and 300 plus contributors. So what I'm going to do is I'm going to go into the demo part now. I'm going to show you how easy it is to get started with Kesque and Pulsar, and the kind of things you can do quickly and easily with the service. So the first thing I want to talk about is Fanout. This is a typical pub-sub type style of messaging where you send a single message and it gets delivered to multiple consumers on a topic. Okay, now I'm going to get this started here. We're going to go over to this is the Kesque dashboard where you get to see all the parts of your service and the topics. And we're going to be looking at this topic called demo, where I'm going to send traffic into this topic, and I'm going to fan it out to 5 different consumers. So I'm going to go over here and start the traffic. Now this is a Java tool actually for performance testing and generating traffic and things. So what I've done here is I've started up the producers, so that's the client that's generating the traffic, and I've started up 5 consumers. So I'm sending in messages at 1,000 messages per second on the producer, which you can see here in the throughput produce line. There's the multiple clients are interleaved here in the output, and you can see that the throughput received is a 5,000 messages per second. So we're sending in 1,000 messages per second. Kesque is taking the rate and it's distributing it to 5 different consumers, so you get 5 times the output. If we go back to the dashboard, we can see this. Here, this is the dashboard. This is the demo topic. You can see the rates take a little while to catch up because they're sampled over a minute or so. But you can see that the rate in is 1,000 messages per second, and the rate out is approaching 5,000. Once it gets a little more time, it will round up to 5,000. And we can see how this is done. On a topic, there's something called a subscription. We talk about here in the Fanout. This is how you create a Fanout scenario. You add multiple subscriptions to your topic, and these subscriptions are durable. Okay, they are remembered, they survive restarts and things. And for each subscription, a client receives a copy of the messages. And they can be easily deleted and added. There's no pre-configuration you need to do, or no complex kind of 2-tier configuration. That's just a simple create a subscription, attach a client to it, and that's what we have here in the Fanout scenario. Okay, we have 5 different subscriptions: sub 0, 1, 2, 3, and 4, and each one of those has 1 consumer connected to it. And the message rate out, as you can see, is now approaching exactly 1,000 messages per second on each one of these subscriptions. If we look at the producers, like I said, we have one producer is producing 1,000 messages per second, and we have 5 consumers, one on each subscription, as you can see here, receiving 1,000 messages per second. That's how easy it is to do a Fanout scenario with Kesque and Pulsar clients. So I'm just going to stop that now. The next thing I want to talk about is another common pattern that you see when doing messaging, building any kind of messaging centric app or event-centric app, is the competing consumer pattern, which is essentially like a work queue type pattern where you send in messages and then you distribute them to multiple consumers of that topic, in this case, to distribute the work between them. Classic work queue kind of scenario where you have each message or event in the topic represents some bit of work to do, and it takes a while to do the work, so you want to distribute the work among several worker applications, or in the case of Kubernetes or something like that, a bunch of worker pods that are going through all of this work. So I'm going to show you that now. I'm going to start up competing consumers. Now it's going to be similar to what we did before. We're going to have one producer sending 1,000 messages per second, but this time we have 5 consumers, and the messages are being distributed amongst the 5 consumers in a round-robin fashion. That way we get even load between all of the consumers, and the consumers compete. Essentially, that's what the pattern's called, competing consumers. They compete for the work on the topic. You can see now in the stats, the throughput on that one producer is 1,000 messages a second, and each of the 5 different consumers will get approximately 200 messages per second. This will even out over time. If we go back to the Kesque dashboard, we can see this clearly. Here. We'll look at the demo 2 topic. That's just a filter we have. Now we can see the stats on the Kesque dashboard. We're getting 1,000 messages per second in, and it hasn't quite caught up in the calculations, but we're getting 1,000 messages per second out, and that makes sense. Each message coming in is getting distributed to 5 different clients, but only one message goes to one client instead of before. Each message went, in the Fanout case, each message went to each client. We can look at that in more detail. Again, a subscription is required to do this, but in this case, we're going to use a single subscription, and all the consumers are going to connect to that one subscription. In this case, this subscription type is called a shared subscription. So we see here we have 5 consumers, and they're connected to this one subscription called Compete. And if we look at the producers, like before, we're getting a producer sending 1,000 messages per second, and we have 5 consumers. But in this case, the consumers are getting about 200 messages per second on each, for each. And so between the 5 of them, they're consuming all the messages that are coming on this topic, and working through the backlog of the work in the queue, so to speak. Let's stop that. Okay, so that's 2 very common patterns that you see when doing messaging, and these are really easy to do in Kesque using Pulsar. One thing I should mention there is that to get those extra consumers on that topic, I didn't have to create partitions or do any configuration at all. This is all dynamically done as the clients connect and register their interest in the subscription. If I added another consumer, it would automatically start picking up its share of the work to do in the topic. If I remove a consumer, it'll automatically start sending the messages in a round-robin fashion to the remaining consumers. No configuration, nothing to be done there. It's all dynamic and totally controlled by the consumer side as the consumers come and go. So one of the things that you don't have to do, and if you're familiar with some of the other systems out there, is we don't have to create partitions to create this competing consumer scenario. However, Kesque and Pulsar support partitions, And there's different reasons why you want to use partitions. You take your topic and you split it into separate partitions. And one of the key reasons for doing that is to get ordering guarantees. So in that competing consumers case, if it's important that the messages are in the order, you're not going to get that with the standard shared subscription, because the consumers are competing for the work and there's no guarantee what order they're going to come in. Partitions, though, if you publish your messages and there's a key on the message, the partitions guarantee that messages with the same key go into the same partition. So this means that you can have ordering guarantees on a per partition basis. The other useful case for partitions is to increase the throughput. Okay, partitions are a unit of parallelism, and so they allow you to basically chop up your topic into multiple smaller parts, which can each individually be scaled up. I'm going to just start up a partition topic, and we'll see this is a little different in the Kesque dashboard. We'll go over to the dashboard right now. I'll show it to you. We'll switch this to a partition topic. Okay, so now what we see in the dashboard is we have, this is the name of the partition topic, the overarching name of it, demo part. And this topic has 5 partitions, similar to what we were doing before. And we can see the partitions here, each partition. And actually, now you can see it right now. The effect is the same as the single shared subscription. We're getting messages in from one producer at 1,000 messages per second. And we have 5 consumers, one on each partition, and the messages going out are 200 messages per second. Okay, but we go back here, we can see in this case there's individual partition topics, one for each of the partitions, 0, 1, 2, 3, and 4. And so when the messages are coming in, they're basically getting sent to one of these partitions, and then the consumers are connecting to these partitions and reading the messages off of them. We get the same effect as the competing consumer. If we were sending messages with keys, which we're not in this case, then we would have ordering guarantees on a per partition basis. Also, if we wanted to really crank up the rates on this, then we could support much higher throughput through the parallelism that we get with partitions. So those are the 2 use cases that we get with partitions. I like to say with Pulsar and Kesque, partitions are, you can use partitions, but you don't necessarily have to use them. It's a lot simpler to not have to use them, but if you do want to use them and you want to take advantage of some of the use cases for partitions, they're totally supported, and you can do that without a problem. One other thing I'll mention just for the ordering guarantee, Pulsar has another type of subscription. We looked at the shared subscription when we're talking about competing consumers. There's another subscription called key shared, which is similar to the shared in that you connect multiple consumers to the single subscription. But what it does, it looks at the keys on the message and it will make sure that the keys are delivered to the same consumer. So they have sort of the ordering guarantee. It has the ordering guarantees of partition, but without the overhead of having to configure partitions and to get it to work. I should have mentioned that we had to pre-configure the partitions, and partitions can grow. You can add more partitions to a topic, but they won't shrink. You can't reduce the number of partitions on a topic. So I'm going to stop the partitions now. The partition messaging here. Okay. Now, as a messaging system, one key feature that several messaging systems, and I say log-based systems because Pulsar is a log-based system where we're appending messages to a log and we're reading them back from that log. That gives us that kind of paradigm, that kind of setup gives us a lot of power in being able to replay messages. Okay, so in a traditional kind of sort of queue environment, a traditional message bus, once a message has been acknowledged or consumed, it's gone, it gets deleted. In the case of Pulsar and Kesque, the message remains for a configurable amount of time, and we can kind of go back in time and play it back and see what happened again. This is very handy for debugging scenarios or for testing new applications to replay the messages that actually were part of the system and see how it responds. So I'm going to show you how an easy way to do how easily we can do that. We're going to switch over to back to the demo topic, the first topic we used. Here, I'm going to take a look at that, and we're going to look at the subscriptions on this topic. Remember, there's 5 subscriptions on here, one for each consumer, so we get a Fanout scenario happening. And you can see in each subscription, the backlog, the number of messages that are waiting to be delivered is 0. That's because when I showed this earlier, the producers were sending messages in, the consumers were all connected, and they consumed all the messages as they were being produced. And Pulsar's quite capable, and Kesque is quite capable of keeping up with the rate. So what I'm going to do now is we're going to roll these, we're going to rewind essentially these subscriptions. And what we'll see as we run the commands to rewind the subscription, it's going to take a couple seconds here. You see what's happening is we're calling an administrative command that rewinds them. And we could do it here in the UI as well. There's a button, but I'm just using a command here. We can rewind this back in time. So these are all the messages that we already consumed in each one of these subscriptions. We can actually skip forward here. If we want, we can move all around in the subscription here. We can skip them all the way up to and now it's empty, or we can rewind it all the way back like we did the first time. Let's just rewind it in time here. So now we can do this in the UI, or it can be done with commands on some of the higher level plans. But now we have this backlog, and when we press enter here, we're going to connect the consumers again like we did before. And you're going to see that all those messages are going to, in this case, very quickly get played back again to the consumers. And they'll be consumed from the backlog of each one of these. So we've just basically replayed the entire scenario that we did in the very beginning as far as the messages go. It'll just take a couple seconds here, and these should all drain to 0, as they're 0 now. And you'll see that, the number of messages received is the rate here. But you can see we've received all the messages. Now we have no throughput, so we're done. It's empty. So we drained all of those subscriptions. So that's Kesque and Pulsar's capabilities as far as sort of traditional messaging and streaming kind of capabilities, which is very powerful. But what you can do is it has more than that. You can combine something called functions. We have something called functions, which allow you to extend the capabilities of your messaging system to perform actions per message as the messages flow through the system. Okay, these are small functions. These are small bits of code that execute per function, and you can do things like based on the content of the message or some sort of property of a message, route the message to a different topic. You can kind of clean up the message, maybe if the message is malformed, delete, skip it, or you can maybe call out to a service of some sort and enrich the message by getting some additional data. And then the flow is you take the message in, the function reads the message, does something to it, does something with it, and then typically produces the message, sends the message back out on another topic. Kesque supports functions written in Java, Python, and Go. I'm going to show you quickly one of those. So we go here to the functions dashboard. We go here and we can add a function. We're going to add a very simple function here. This function is written in Python. I'll just add it to this. I'll add the topic. So this is a topic it's going to read from. So every message coming in on the exclaim input topic, and this function just adds an exclamation mark to any string. It's very simple. And then it's going to have an output topic. So messages coming in on this topic exclaim input are going to go to the function. The function is going to append an exclamation mark onto the message, and then it's going to output it into the output topic. You can see down here is the code preview. This is what the code is. It's only 2 lines. this is Python code. It comes in, it returns the input with an exclamation mark after it. Okay, so we take that code. We can write any code we want, in Python and Java and Go, and we can upload it into the system. And then after a couple seconds, it gets loaded and it's running. It's now running inside Kesque, and it's ready to go. There's a quick tool here just to test it, so we can trigger the function. So basically, we're going to send a message onto the input topic and receive something on the output topic. Click on that. We sent in the text, say hello to my friend, and we got the response, say hello to my friend with an exclamation mark. It's that simple. You can process messages. You can do things much more complicated than that, obviously. Here we can see some stats. We received one message. We successfully processed it. And then it tells you the stats on the function. So this is a very powerful way of extending the processing or extending your messaging and doing lots of interesting things with the messages as they flow through Kesque and Pulsar. The last thing I want to talk about is another powerful part of the system is sinks and sources. So data that you're moving around comes from different places. There's standard databases, other messaging systems, and so you want to have an easy way to get data from one source system into another system. And with Kesque, we support that, and we have a number of built-in what we call sinks and sources. Sources take data from some system and put them into Kesque, and sinks take data out of Kesque and put them into some other system. Examples are, using JDBC connectors to sync data into MySQL, Postgres, Mongo. So we can take data published into Kesque and we'll dump it into MySQL tables or Postgres. The other side of the coin, sources, if you're looking at database source, you can do change data capture, which means as data changes in a database, we're going to stream that out as an event, and then we're going to publish it into Kesque. So I have an example of that for you. In our sinks. Now this is a little more involved in setting it up, so I've already set it up already. This particular sink is a Cassandra sink. Data that we publish into Pulsar ends up in Cassandra, and this is using the DataStax Astra implementation of Cassandra. They're online. They're Cassandra as a service. That's relatively new, but it works well. So we're going to connect to this cluster, which I'll just quickly show you here, is defined in running in Astra, and I have a console here. Oops, and I have a table. Select star from products. So we have a table called products. Right now the table is empty, but what we're going to do is we're going to go here, and we have a small Python program that I wrote that publishes messages into Kesque. It's going to take those messages, it's going to process them, it's going to turn them into rows in that table. Here in Cassandra, we'll go here. We can go. We'll look at Cassandra now, and we'll do a select, and now that published 10 messages. Those 10 messages have turned into 10 rows in the Cassandra table as a sink. So that's how easy it is to get data in and out and processed through Kesque and Pulsar. So that's it for my demo. You can sign up for a free plan and try out some of this stuff at https://kesque.com. You can try out PubSub, competing super, all the things I showed you. You can try that out. If you have any problems, send us an email at support@kesque.com, or there's a support widget on the right-hand side of the dashboard. Right here. Click on that. Enter your text. Let us know what's going on. And that's it. I hope you liked it. Thanks.